Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is the lecture video, lecture sample problem videos on general friction. So this series of examples will show you the solutions to basic problems on friction. And what is important is we have to compare friction to the maximum frictional resistance on a surface, contacting surface, so that the system will be in equilibrium, and if the system or a body will keep on moving here. Level 1, in the figure shown below, determine the force P required to start the lower block to the right. The coefficient of static friction between the upper and the lower block is zero point 0.4, while between the lower and the floor is 0.3. Consider two cases. Letter A, theta is 0 degree, and letter B, theta is 30 degrees. So for the solution, we need to draw the free body diagram and set up equations of statics to answer the questions. So first, for the upper block, so let's draw the free body diagram in general. So we have the block, its weight 200 newtons, then the normal reaction, call that N1. Then we have tension, which makes an angle of theta in general. Then friction, because in the question is to compute for determine the value of P required to start the lower block to the right, so that means we have impending motion. Therefore, the maximum frictional resistance for impending motion is 0.4 of the normal, so we have 0.4 of N1, which is rightward on this upper block, at the bottom of the upper block. Then let's transmit this normal and frictional resistances on the lower block by action-reaction principle. So they are now opposite because these are internal reactions. So we have the weight 500 newtons, N1 downward, zero point 0.4 of N1 leftward. And at the bottom we have N2. Then friction, which is opposite to the possible impending motion, which is to the right, so it is to the left. And it is also maximum. So mu sub S 0.3 times N2 to the left. So therefore, summation forces horizontal for this lower block P is equal to 0.4 of N1 must be greater than equal to 0.4 of N1 plus 0.3 of N2. So P is greater than 0.4 of N1 plus 0.3 of N2. Well, for N1 in the upper block, summation forces vertical equals 0. So we have our normal axis, summation forces along the normal axis equals 0. So we have N1 plus T sine of theta then equals 200. So substitute the value of theta, which is 0. So N1 plus 0, T sine of 0 rather, equals 200. So N1 equals 200 newtons. Then for the lower block, take note N1 is 200. So N2 minus 500 minus N1 equals 0. So since N1 is 200, N2 equals 700 newtons. So substitute into this equation, P must be greater than equal to 0.4 of 200 plus 0.3 of 700. So solving for P, P must be greater than equal to 2900 newtons. Sorry, 290 newtons. Then for part B, let's solve for N1 again into this equation. So N1 plus T sine of 30 degrees equals 200. Then summation forces horizontal, zero point 0.4 of N1 minus t cosine of 30 degrees equals 0. So expressing t in terms of N1, t is 0 point 0.4 of N1 divided by cosine 30. So t is 0.46188 of N1. Substitute here in this equation. So N1 plus 0.46188 N1 times sine of 30 equals 200. So N1 can now be found. N1 is equal to 162.48 newtons. Then N2 minus 500 minus N1, which is 162.48 from this equation here, equals 0. So N2 equals 662.48 newtons. Finally, substitute here. P must be greater or equal to 0 point 0.4 of N1 162.48 plus 0.3 of 662.48. So P should be greater or equal to 263.7 newtons. So that's it for this problem. Level 2 problem: determine whether the block shown is in equilibrium and find the magnitude and direction of the friction force when part A, P is 150 newtons, and part B, P is 400 newtons. So here's the figure. For the solution, let's draw the free body diagram, and let's superimpose the normal and the tangential axis in this figure as shown. So for the friction, we do not know if the block tends to move up or down, or it will keep on moving up or down. So since the condition is just to determine whether the block shown is in equilibrium, and then we find the magnitude and direction of the frictional force. So let's compute the maximum frictional resistance when the block is in motion, which is mu sub k times normal, and the maximum frictional resistance when the block is in equilibrium, or we have impending motion, which is 0.3 of the normal. So this is 20 degrees, this is also 20 degrees, and the friction is in either direction. As shown, we will just call that F. So first, summation forces along the normal axis equals 0. So N equals 500 cosine of 20 plus P sine of 20, where P in part A is 150. So therefore, N is equal to 521.15 newtons. Then let's evaluate maximum frictional resistance when the body is in motion, which is Fk max. So Fk max is mu sub k, which is 0.25 of N, 521.15, so it is 130.29 newtons. Then F max, when we have impending motion or the block is in equilibrium, the maximum frictional resistance is 0.3 of 521.15, so 156.34 newtons. So let's now have our static equation, summation forces along the tangential axis, and let's solve for F, which requires the value of F, which will make this system in equilibrium. Let's assume it is frictional resistance is rightward, or the block tends to move upward. So let's assume it is rightward. So 500 sine of 20 minus P 150 cosine of 20, then minus F. So because we have minus F, meaning to say the assumption is F is in that direction, upward. So the block in my assumption in this equation here tends to move down. So minus F equals 0. So again, this is the direction in this equation here. So F is equal to 30.06 newtons since this is less than F max, which is 156.34 newtons. F is 30.06, the frictional resistance required so that this block remains in equilibrium. And since this is less than the maximum frictional resistance of the block for it to remain in equilibrium, therefore the block is indeed in equilibrium. And because it is in equilibrium, the maximum frictional resistance or the frictional resistance for the block to remain in equilibrium is 30.06. So the conclusion, the block is in equilibrium and frictional resistance is 30.06, which is up to the right and an angle of 20 degrees to the horizontal. So block is in equilibrium, frictional resistance is 30.06 newtons at 20 degrees to the horizontal, up to the left or along the inclined plane. Then for part B, P is 400. So let's solve for N again. So N is 500 cosine 20 plus 400 sine of 20 degrees. So N this time is 606.65 newtons. Maximum frictional resistance if the block is in motion, Fk max is 0.25 of 606.65, so it is 151.66 newtons, and F max, maximum frictional resistance for the block to remain in equilibrium, is 0.3 of 606.65, 182 newtons. Then, same assumption, this frictional resistance is up to the left, so summation forces along the tangential axis equals 0. So 500 sine of 20 minus 400 cosine of 20 minus F equals 0. So F is negative 204.87. Since it is negative, it means that it is wrongly directed. So F is going down in this direction. So this is the correct direction of F. And let's compare that F, which is 204.87, down the plane, which will make this block in equilibrium to the maximum frictional resistance, which is 182.0. So since 204.87 newtons is greater than the maximum frictional resistance, which will make the block in equilibrium, it means that the block moves or slides. Because the block slides upward, so friction is going down. And since when the block is in motion, the maximum frictional resistance is equal to this maximum frictional resistance for the dynamic case, which is Fk max. Therefore, the maximum frictional resistance that will develop is only 151.7 newtons. So the answer, F is equal to Fk max 151.7 newtons because the block is in motion. So F equals, this is the force that will require this block to be in equilibrium, but because this is greater than F max 182.0, so that means the block is in motion. It slides up the plane, and the maximum frictional resistance for moving bodies is Fk max. So that's why the answer is 151.7 newtons. So block moves up, F equals Fk max 151.7 newtons at 20 degrees to horizontal. So it is down the plane. Level 3, determine whether the block shown is in equilibrium and find the magnitude and direction of the friction force when P is 600 newtons. So here is the figure, and for the solution, let's again draw superimpose the normal and the tangential axis as shown. The figure. So the measure of this angle is 30 degrees. So friction is in either direction along the plane. And this is 30 degrees. So let's call the normal reaction as NF. Summation forces along the normal axis equals 0. So NF equals 250 cosine 30 plus P sine of 40 degrees, where P is 600. So NF is equal to 602.18 newtons. So the maximum frictional resistance when the block is in motion, Fk max, is zero point 0.3 of NF, 6.3 of 602.18, so 180.65 newtons. And the maximum frictional resistance for the block to remain in equilibrium, or when we have impending motion, is zero point 0.4 of NF. So zero point 0.4 of 602.18 is equal to 240.87 newtons. Then let's solve for F required for the system to be in equilibrium and compare it with F max here. And then we decide if the block remains in equilibrium or not. So F, assuming that F is down to the right, so F plus the tangential component of 250 sine of 30, which is in that direction, then minus P, which is 600 cosine of 40, which is this, equals 0. So F is equal to 334.63 newtons, which is correct. So it is in that direction. And let's compare it with the maximum frictional resistance for the block to remain in equilibrium, which is 240.87. Since 334.63 is greater than 240.87, so that means that the block, so this is the required force for the block to remain in equilibrium. So that means that the block moves upward, because if it moves upward, friction is going down. And since this is greater than the maximum frictional resistance, which will make the block in equilibrium, therefore the block slides up. Because it slides up, then the maximum frictional resistance that can develop is that of maximum kinetic friction, which is 180.65 newtons. So therefore, F is the block moves, it slides up, and the maximum frictional resistance is 180.7 newtons. At 30 degrees to the horizontal, as shown, down to the right, as shown. Level 4 problem: determine whether the block shown is in equilibrium and find the magnitude and direction of the friction force when P is 400 newtons. So we have the same problem, except that P this time is 400 newtons. For the solution, as usual, we have the normal reaction in F, then superimpose the normal and the tangential axis. We have friction, which is in either direction along the plane. Let's call that F. And this measure of angle is 30 degrees. So NF equals 250 cosine 30 plus P 400 sine of 40 degrees. So NF is equal to 473.62 newtons. Then summation forces along the tangential axis, or let's compute Fk max and F max. So Fk max is 0 point 0.3 of 473.62 newtons, 142.09 newtons. F max is 0 point 0.4 of NF, so it is equal to 189.45 newtons. Then let's sum up forces along the tangential axis. Let's solve for F required for the system to be in equilibrium. So assuming F is down to the right, so F plus tangential component of 250 sine 30, then minus P 400 cosine of 40 each component in that direction equals 0. So F is equal to 181.42 newtons, which is less than 189.45. So this is the maximum frictional resistance for the block to remain in equilibrium, and the required friction that will make the system in equilibrium is only 181.42 newtons, which is less than 189.45. So that means the block is in equilibrium. And because the block is in equilibrium, and this is the required frictional resistance which will make it in equilibrium, therefore this is the answer. And it is directed down to the right. So the block is in equilibrium, and F is 181.4 newtons down to the right at 30 degrees to the horizontal. Level 5, determine the smallest value of P required to letter A, start the block up the incline, B, keep it moving up. So take note, the condition is the smallest value of P required to start the block up the incline. When the block starts to move up the incline, it means that we have impending motion. So the maximum frictional resistance F should be mu sub S of the normal. And to keep it moving, so that means that the block keeps on moving upward, and therefore the maximum frictional resistance, which is downward, is that of kinetic friction, 0.3 of the normal. So we have the normal reaction, and superimpose the normal and the tangential axis, and this is the direction of frictional resistance F, but this should be for part A maximum, which is zero point 0.4 of NF, and for part B 0.3 of NF. And the direction of friction is downward, down to the right, because in both cases the block tends to, for part A, tends to move up, so the maximum friction resistance is down, and for part B, to keep it moving up, so it's still motion is upward, so friction is downward. So NF equals 250 cosine of 30 plus P sine of 40 degrees. So that's F. So F equals F max equals 0.4 of 250 cosine of 30 degrees plus P sine of 40 degrees for part A. Then 250 sine of 30 degrees, summation forces tangential. Then plus F, which is this 0.4 of 250 cosine 30 plus P sine 40, then minus P cosine 40 equals 0. So we equate it to 0 because the block remains in equilibrium, because the condition is the value of P required to start the block up the incline. Simplifying, combining 250 sine 30 and 0.4 of 250 cosine 30, that's 211.6. Then transposing P cosine 40 and 0.4 P sine 40 to the right, factoring out P. So we have cosine 40 minus 0.4 sine of 30. Solving for P is equal to 415.8 newtons. Then in part B, same F, same direction, but its value this time is 0.3 of the normal force. So part B F is Fk max equals 0.3 of 250 cosine 30 plus P sine of 40 degrees. Then summation forces along the tangential axis equals 0. This is the direction of F, and this is the value of F. So 250 sine of 30 plus 0.3 of quantity 250 cosine 30 plus P sine of 40 degrees minus P cosine of 40 degrees equals 0. So combining again, 189.95 equals P quantity cosine 40 minus zero point 0.3 sine of 40 degrees. Solving for P is equal to 331.4 newtons. So that's it for this uh, general friction part 1.